It can scarcely be denied that the supreme goal of all theory is to make the irreducible basic elements as simple and as few as possible, without having to surrender the adequate representation of a single datum of experience. Albert Einstein, 10th of June 1933. When this idea took its own advice and simplified itself, it became better known as Einstein's razor. Taking it one step further, we run into the very problem he wanted to avoid. The traditional J display is a beautifully elegant way to show the value of an array. Unfortunately, it's a little too simple to be able to display shape information unless we do some additional work with the shape primitive. The following examples will show that by generating just a little CSS and HTML, the shapes of arrays can be shown just as clearly and unambiguously as the values the arrays contain. So to begin, let's take a quick look at how the different types are displayed as atoms. The key to the atom display is that the only shape you see is of the atom itself, which is intuitively appropriate. Hovering over the display reveals the type in a text format. And some of the text displays contain extra information, such as the ASCII value of the character literals, and in the case of boxed atoms, both the information about the box and the contents it contains. And now we'll move on to the display of differently shaped arrays. To make things a little easier, I have defined these arrays as variables where the last digits in the name correspond to the shape of the array represented. You can see that both the text version and the HTML version of the display use the layout in similar ways to convey the shape of the array effectively. If this were the limit of the arrays to be displayed, there would be little reason to use the HTML version, as it actually takes up a little more space and is a little noisier than the traditional text display. One thing that the HTML display does possess is the ability to display shapes by simply hovering over the part of the array that holds your interest. This is where things get a little more interesting, because we see that by putting a 1 in the first value of an array shape, the text display is identical to the display of a shape one rank lower. To complicate things a little further, when the leading value of the shape is not 1, then changes do affect the way the shape is displayed in both the HTML and the text versions. The advantage that the HTML holds is it shows the differences consistently across all shape changes. And in the case of the one-item vector, the presence of the outside container distinguishes it from the atom with the same value. This next example of displaying is where the HTML method really distinguishes itself. Using the integer verb to create arrays, we see that as soon as there is a 0 as the first value of the shape, that array is displayed as a blank line. This means that every array of a different shape that starts with 0 will consistently appear to be a blank line. With the HTML version, the atom in the center of the display is empty, and the display shows 0 values of the shape as white, whereas the non-zero dimensions appear as different shades of gray. Also, as we've seen before, hovering gives us the shape of each component in text display, as well as the type of atom that would be present if one existed. You can see that each array has a distinct view in HTML, depending on its shape, no matter where the 0 values appear in the shape, and no matter the number of them that may occur. This becomes important because the behavior of arrays when acted on by verbs can depend on the shape of the array. So in this case, we can see that the text displays of 020 and 030 shaped arrays are identical. The HTML version shows the 020 and 030 as different, giving us an important clue as to the outcome we can expect from appending to a two-element vector. The zeros in this case are simply a fill pattern, but the pattern of that fill depends on the shape of the original array, and this is where the differing displays in the HTML version become significant. I hope I've shown that in order to show the differences in different shapes consistently, we must introduce just a little more information into our display. If we don't, we run the risk of losing the ability to distinguish between shapes because we've made things too simple. On the next blog post, I'll give some examples of how the new display can clarify our understanding of J operations. A special thanks to Raul and Pascal for their thoughtful responses to the previous blog post. As always, I look forward to your thoughts on this new way of displaying the results of J operations using HTML and CSS in the JHS platform.